Morning. I'm with another that's the structure and I'm going to project and the application that we choose, which is Spotify. So for the application that we're going to pick is Spotify. So Spotify is a digital music, podcast, and video service that gives you access to millions of songs and other content from creators all over the world. So Spotify is a platform that will be used a lot of people from around the globe. Spotify has so many users to able to let them to listen to the music. And the reason why people love Spotify so much because it provide a free streaming music services to the users. And Spotify also use a store list or a data structure, which is a linked list to store just songs in a playlist. User playlist like Spotify use a linked list data structure to store the playlist of songs. So from this, it can make the playlist much more organized for the user to able to play the songs much more easier and much more efficient. And because of this, the user would have a much better time to able to listen to music without worrying about a messy playlist. By using a linked list, everything is going to be much more easier by having so many features like skip button, reverse button, and also you can even add or delete any song that you want into the playlist. And because of this data structure, it can make Spotify a platform that can be used easy for the users to able to create their own playlist, listen to their own music, and do whatever they want in their Spotify playlist. Type of data structure use. So what type of data structure use that we use? We are going to use Doubly linked list for our Spotify implementation. A Doubly linked list is used to store the songs in a playlist. This is because it allows for easy insertion and deletion of songs. So Doubly linked list has a four-way to insert a new note. And by this, we can able to insert a new note in a much more quicker and easier way. It also has the ability to quickly traverse the list in either direction. So they can traverse either forward or backward. And because of this, we can manage to skip or reverse song much more easier. Doublet linked list operation. So this is our doublet linked list operation diagram. And as you can see, there are three songs: Oblivion Royal Blood, Honesty Billy Joel, and Nothing You Now. And each of these songs is represented a node. And as you can see, there are next reference variable and previous reference variable. So this next reference variable is going to represent it as a skip button for the Spotify implementation, while previous reference variable is going to represent it as a reverse button for the Spotify implementation. So from this, whenever the operation is whenever is I press the skip button, the first node or the first song is going to reference to the next reference variable to switch to the next song, which is on the stability which is on the second node. And if I want to change to the previous song, I'm just going to press the reverse button and it's going to go to the previous reference variable to able to change to the previous songs, which is the first note and also the first song, Oblivion Royal Blood. So why doublet linked list? Why we choose doublet linked list instead of single linked list? There is the reason why. So on the top is a single linked list, and while the bottom is going to be doublet linked list. So let's take a look at the single linked list first. So the single linked list, they can only move forward, which only one direction. Compared to doublet linked list, they can move two directions. The first one is forward, and the second one is backward. And because of this, WSync is much more suitable for the Spotify because of the feature of skip button and reverse button require a forward and backward movement. And the second one is WLink list has a four ways to add a new node. first one is from the front, second from the back, third is before the note, and the fourth is the after the note. Compared to single linked list, there are only two ways, which is from the front and also from the back. And by this, we can see that the doubly linked list has much more ways to add new node, and because of this, we can go to the process of insertion and deletion much more quicker and much more easier for the doubly linked list, which is going to be suitable for the Spotify. However, doubly linked list has their own disadvantage, which is they use much more memory compared to single linked list. This is because of they have an extra pointer or extra reference variable, which is the previous reference variable, which require an extra memory. However, we have to keep in mind that we are using a Spotify playlist which also had a large memory, while the single linked list, they are only suitable for a limited memory space, while Spotify have a big memory space which is really suitable for the doubly linked list to be implemented.
So we look into how the general structure of the doubly linked list. If you notice, I did not extend the linked list class for the class playlist. This is by design for this particular demo. Since it's the demo layer, I will be using string input to do the operations. However, going through the methods, I will be explaining the equivalent methods that is built in for the linked list in the Java if we want to extend the class instead of implementing manually like I did. So essentially, we need three elements to the any doubly linked list. So the first one is obviously the item, which is whatever object or variable that we want to use. So for the Spotify example here, since we are simulating the playlist, this item will be the song or the MP3 file. But for the sake of the prototype and demo, we will be using string type object called item to make it easier to portray later in the demo. The next element is the previous, which is, as the name suggests, contains the information of the previous item in the doubly linked list. For the head of the doubly linked list, the previous will always be null. For example, the previous of our third index is the second index, etc. The last element is the next, which is the location for the next item in the doubly linked list. For the tail of the doubly linked list, the previous will always be, the next will always be null. For example, the next of the fourth index is fifth index. In the event that the head is null, this just means that the doubly linked list is currently empty.
Add a new song. So the playlist has a feature to add a new song. So how it's going to look like in a doubly linked list? So for this scenario, we're going to add a new note or a new song, which called Sunny Day by Doubly, into this playlist. And from there, you can see that to able to add a new note or a new songs, the next pointer has to point to the first note, which is the oblivion, while the previous reference variable from the first note has to point to the new note. And from this, they can be able to move the head to the new note. And now, as you can see, the new note has become the first note, while the first note has become the second note. And after that, the new song Sarida has been added to the playlist as the first note, while the Oblivion, which is the previously a first note, has now turned into a second note, because right now the head is on the sunny day, which is the first note.
To add a song, I have created a void method called add playlist. For the equivalent built-in Java linked list method, we have the add method that will essentially do the same thing. However, I will be implementing the method manually in the example so that the algorithm is easier to be seen and understood. In this example, it is taking a string object type as the parameter. Of course, in the ideal world, we will have another class created for song that contains the MP3 file and all related files and informations for the song, such as the album, artist, etc. So taking in the parameter song, we are creating a new playlist object called new song to be inserted into the doubly linked list. First thing we need to do is to check whether the playlist is empty or not, which I already mentioned earlier can be done by checking then if the head is null. If the head is null, it indicates the doubly linked list is empty. Hence, we can set both the head and the tail to be the value of the new song, making it a single entry doubly linked list. Otherwise, we will take the current tail next and pin it to the new song. At the same time, set the previous for the new song to the current tail, and then finally reset the tail to be new song. So effectively the new entry will be the new tail for the playlist. We should also not forget to reset the next for the tail to be null. Again, for this example, we won't be talking about rearranging the songs in the playlist. We do know that in the actual Spotify playlist, users can sort according to song name, artist, or the default sorting, which is based on the date added. But for simplicity's sake, we would stick to the default sorting, which is the by the date added sorting.
Delete a song. So right now we're going to delete a song for the playlist. So the song that we're going to delete is the first note or the first song, which is Sunny Day by Biba Doobie. And to be able to delete the song, first we have to move the head to the second note, and then we have to set the previous variable for the second note, which is oblivion, as a null. And the reason we are doing this is because we want to keep the previous pointer to not have any reference variable to able to delete the first node. And now after delete the first node, the second node right now is become the head, and right now they have also become the first node for this playlist. And now the sunny day has been removed. The playlist right now has changed the first node, which is the oblivion royal blood, which is previously the second node, but now has turned into the first node because the first node has been deleted from the playlist. And other than that, the honesty Baby Joel is going to become the second node, which is previously third node, and Asim Bayuna is going to become the third node, which is previously a fourth node.
So it is a bit complicated to remove a song because unlike the previous method of adding a song, it does allow for removing an entry that is not a head or the tail. So essentially you can pick whichever entry to be removed. So it works relatively the same way as the remove object method for Java linked list. I created a void method called remove playlist. So the method takes in a string type object as the parameter again. The method essentially starts with creating an index of the desired song to be removed. So we would check if the desired song to be removed actually exists in the playlist first by calling the method contain song, which is equivalent to the method contain for Java linked list. But we will explore the details of this contain song method in the next slide after this. The index would return the value of -1 in integer if the desired song to be removed does not exist in the playlist, or retains the actual index of the first occurrence of the desired song to be removed from the playlist. In the event that the song does exist in the playlist, I created a temporary object called remove song, initialized to be the head of the playlist. This essentially serves as the purpose as an iterative and later can be the actual song to be removed. Using the index variable, we can get to the desired song to be removed as the current item by iterating over the playlist. After that, we need to adjust both the previous and the next of the removed song so that the playlist is not hanging off when an entry is taken off from the playlist itself. So for the previous, we would check if remove song is the head or not first. If it is the head, then the next of the remove song would be the new head. Otherwise, we would take next, the remove the next of remove song to be the next of the previous of the remove song. For example, if the remove song is entry number 4 in the playlist, the next of remove song, which is entry number 5, would be the previous of yeah. So the next of the remove song is the entry number 5. Then the previous of remove song is entry number 3. So the sequence will be going from 3, 4, 5 and into 3, 5. But of course, the actual index does change as well. So the entry number 5 is now entry number 4, replacing remove song. So it is relatively the same process for the next part. We would check if remove song is the tail or not instead of the head. So if it is the tail, then the previous of remove song will be the new tail. Otherwise, we would take the previous of remove song to be the previous of the next of remove song. So for example, again, if remove song is entry number 8, the previous of remove song, which is entry number 7, would be the next. We will be the previous of the next of remove song, which is entry number 9. So the sequence will be from 789 into 79. But again, the actual index does change as well. So now the entry number 9 is replacing remove sound to be entry number 8. Lastly, after the actual removing of the song is completed, the user will be prompted with a system notification saying the song has been removed from the playlist. In the event that the song not being in the playlist, the user will get the notification. It's simple. Of course, in the actual Spotify app, the user can even try to delete a non-entry. So that does require the user to see all the playlists first and only have the option to remove whatever in the playlist. Whereas in this example, we are using a preemptive input to simulate the process of deleting a song. So this is the contain song method, which was used in the remove playlist method before. The method is accepting the same string type object as the parameter, but unlike the previous two methods, it does have a return of an integer type variable. So the method starts with creating a temporary playlist object called current post that is initialized with the head. We also need the index variable, which in this method is represented with the variable I initialized to the value 0. We are going to have a while loop to check every entry that exists in the playlist. We will then compare the desired sound with the current entry. If it is the same, the current index will be written. Otherwise, the loop will continue until all the entries are checked. Only the first occurrence will be recorded as the index and the method will end. In the event that either the desired song is not found in the playlist or the playlist itself is empty, the method will return the integer value of -1, which will be used to in the remove playlist method afterwards.
A common algorithm that typically operates on the whole playlist data structure is a shuffle algorithm. Modern Spotify shuffle algorithm is very sophisticated and takes user listening preferences as part of the input data. But at first, Spotify shuffle was implemented as a simple true random shuffle. The code for this shuffle can still be found today. This implementation that we are looking at is in JavaScript. It takes as input parameter an array of size n elements, where n is at least more than 1. It then returns a shuffled version of the array. The efficiency of this algorithm for input of size n is order n. We can see this by analyzing the total number of statements executed by this algorithm for input size n, and then discarding any constants and lower order terms. The first statement executes once for input size n. It simply checks if n is less than 2 elements and returns it, since the algorithm cannot shuffle one element. The second executes n times for input size n, since it is in a for loop that executes input n times. So does the third, fourth, and fifth statements, which are also part of the for loop. What this loop does is it iterates each element in the array and swaps its position with a randomly selected element in the array. The last statement is also executed once. So for this entire algorithm, the total number of statements is 4n plus 2, which simplifies to n. Therefore, the efficiency of this algorithm in the worst case is order n.
Now we have the demo part for the algorithm. So this is the output method print playlist, which serve to print all the entries from the playlist. We again start with a temporary playlist object called turn, initialized with the head of the playlist. So checking first if the playlist is empty, which will give a system notification to the user and immediately exit the method. Otherwise, the method will print songs in the playlist, iterating through the entries one by one until the tail using an integer variable called counter as the numbering for the list. We have the main method here to simulate what we have set up for the playlist and the Doubly linked list class object earlier. Essentially, we want to create a playlist using the Doubly link, link list class. In this example, the object is called song playlist. Then using the add playlist method, we will be using the song name in the string as the input parameter for the method that it will be used as the item for each entry. So we have Sunny Day, Oblivion by Royal Blood, Honesty by Billy Joel, Asing by Yuna, and Morena for our songs in the playlist as example. So as we can see here, this will be the desired output from what we have put as the methods. Essentially, this is the print playlist method, putting the list as an output in the terminal. Now, if we add in the statement in the main method to utilize the remove playlist method, let's try to remove async Yuna for async by Yuna for the first example. And as expected, since the song async by Yuna does exist in the playlist, it is removed from the playlist, and then the playlist itself updates the entries and adjusts the indexes accordingly. Now let's try to remove a song that is not in the playlist. Let's say Sumpah by Naim Daniel. So the app does not like that, and we did receive the error message saying that the song does not exist in the playlist. And as we can see, the playlist is retained when an invalid remove request is invoked. So for the last demo, let's try to remove that song from the playlist. Let's go, let's say Honesty by Billy Joel. We can see how all of the songs after Honesty by Billy Joel was adjusted one number up to make up for the lost space in the playlist. So that is all for the demo for our Spotify app that is showing how the data structure of doubly linked list works for playlists.
In conclusion, the unique properties of a doubly linked list makes it especially suitable for implementing a playlist data structure with. All of the most common operations used on playlists are trivial and efficient, thanks to the way the doubly linked list is structured. Users can have massive playlists and still efficiently insert and remove songs from it at any index in the list. Users can also efficiently check upcoming songs, skip songs, or go back. Thank you for watching our presentation.